Welcome back. Ellipses. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points f1 and f2 is a constant. These 2 points are called the foci of the ellipse. Foci is plural of focus. Okay, one focus, two foci. So f1 and f2 are foci. What does this mean? Well, take a string, a loose string, okay, and hold your pencil here and move the pencil. So you can see this length of the total length of the string is the same, but you get a whole bunch of points, okay. So this curve is called ellipse. So length of the string does not change, mind you, right? Length of the string does not change. The sum of the two lengths here, that is length of the entire string. So let P xy be a point on the curve, on the ellipse. Suppose the two foci are on the x-axis. Suppose they are placed equally away from origin. So one is, first focus is negative C0, second focus is at C0. So they are on the x-axis either side of the origin, and your point P is on the ellipse xy. So this length of the string is this length plus this length. Okay, length of the string is greater than the distance between these 2 points. Notice distance between f1 and f2 is twice c, because negative c from here to origin, here to here is c. So in all 2c. So length of the string, let it be called 2a. Sum of the distances from P to the two foci. So this distance plus this distance is the length of the entire string, which is 2a. 2a is greater than 0. In fact, 2a is greater than 2c. All right, keep that in mind. We'll come to it. So distance from P to F1. Use distance formula. X minus c squared plus y minus 0 squared. So that's the distance of P from F1 plus distance of P from F2, x minus c squared plus y minus 0 squared. Add them, take the square root. So that's the second distance. This distance plus second distance is twice a. 2a is the total distance. Okay, length of the entire string, we call it 2a. All right, now move this guy to the other side. That's what we did. Okay, it doesn't matter which one you move, but we moved this one to the other side. Left hand side is root x minus c squared plus y minus 0 squared. Right hand side is 2a minus root x plus c squared plus y minus 0 squared. All right. Square both sides. If I square the left and I square the right, notice right hand side has two terms separated by that negative, that minus. So you need a bracket to square it first, right? Now when you square, the square root goes away. You're left with x minus c quantity squared plus y minus 0 quantity squared equals. This is a square of difference. So you have a complete square formula. 2a squared minus 2 times 2a times the radical plus the radical square. All right. I'll keep it here. Notice the square of the radical, the radical goes away and you have this expression. 2a squared is 4a squared, 2 times 2a is 4a. So that's the only change. Now open this using complete square formula. You have something here. Y minus 0 is y, squared is y squared. 4a squared minus 4a radical plus this quantity. Now you can open this. Aha. And there, y squared. All right, now we are ready to cancel things. Notice x squared here cancels x squared here. C squared y squared, c squared y squared. So on the left, all you are left with is negative 2cx. On the right, 4a squared minus 4a times radical plus 2cx. Move the 2cx over there, you get negative 4cx. 4 is a common factor. Divide both sides by 4. You're left with negative cx here, a squared minus a times the radical. Now move negative a radical to the left, move negative cx to the right, and this is the expression you have. This is the equation you have. Square both sides. Right hand side is a complete square. Left hand side, a squared and the radical disappears. Right? A squared you get and the radical disappears. So notice I have two terms. I had two terms inside the radical. So I have two terms. I have to distribute the a squared to both. Open this. Further open, distribute a squared, and you have an entire expression. Out here, you have x squared here. By the way, 2a squared cx, 2a squared cx, they cancel. Now, you have x squared here, and y squared here, constant here. So, what do? Keep x squared terms together. A squared x squared minus c squared x squared together. Keep y squared term on the left. Move the constant to the other side. A to the fourth minus a squared c squared. Notice you can factor a squared out. Here everything is the same. Aha. Divide both sides by a squared times a squared minus c squared. All right. Once you do that, this gives you 1. Here a squareds cancel, and here a squared minus c squareds cancel. All right. At this point, you can call a squared minus c squared to be b squared. Why? If you recall, I said the length of the string is more than this distance, you see, as you can see. So 2a is greater than 2c. That is, a is greater than c. Because a is greater than c, a squared is greater than c squared. So a squared minus c squared is a positive number. Because it is a positive number, I can write it as a square of some real number. Hence, you can write b squared. So, a squared minus c squared is b squared. You have x squared over a squared plus y squared over b squared equals 1. This is your ellipse. How do you find x intercepts? You get x intercept by setting y0. If you set y0, this term goes away. X squared over a squared is 1. That is, x squared equals a squared, x equals plus a or minus a. These are called vertices. When you have x-intercept, a0, negative a0. Likewise, y-intercepts. How do you get y-intercept? Set x is 0. This goes away. Y squared over b squared is 1. Y squared is b squared. Y becomes b or negative b. So notice that's the y coordinate. All right. Always we look for a greater than b. You will see in a minute what I mean. A0, negative A0. Those were your x-intercepts. They are called vertices when your foci are on the x-axis. 0b, 0 negative b. They are called co-vertices. A squared minus c squared is less than a squared. Therefore, we have b less than a. The line segment joining 0b and 0 negative b, that is the co-vertices. It's called minor axis. The line segment joining A0 and negative A0, that is vertices, that's called major axis. If the foci agree, then C has to be 0. A will be B, your ellipse becomes a circle centered at origin. Alright. All of this discussion holds true because your foci are on the x-axis. So summary. First, if your foci are on the x-axis, then A to negative A, this is called major axis. B to negative B, that's called minor axis. A is greater than or equal B. If the two foci agree, that is they meet here, they are one and the same point, then what you have is a circle. All right. The larger, the major axis vertices, they are called vertices, intercepts, right? And the minor axis intercepts are called co-vertices. All right, this is when foci are on the x-axis. If foci are on the y-axis, then A corresponds to y coordinate. So notice A is written with the y. When foci is on the x-axis, A goes with the x. The bigger number, the bigger A, among A and B, the bigger value determines where the foci is, you see, a foci are. Anyhow, the foci are on the y-axis, A goes with y, B goes with x. So A is 0A, A is a y-intercept. Negative A is a y-intercept. So 0A, 0, negative A are y-intercepts. They are your vertices. Whereas the x-intercepts now are co-vertices. This is your major axis. This is your minor axis. Let's look at an example. Sketch the graph given by the equation 25x squared plus 16y squared, that should be a y, equals 121. Okay. Identify the foci. Well, okay. So we need 1 here. So let's divide by 121. When you divide by 121, you get 25 over 121. Notice I need x squared over some quantity. So I'll write the 25 below. All right. So now look at these two numbers. Which of these two numbers are bigger? That's the bigger one. 121 over 16, you see, that's a smaller denominator. So this is bigger. So that's going to be a squared. A squared is the larger square, larger denominator. In other words, because A goes 121 over 16 is A squared, my foci are on the y-axis. B squared is the smaller one. B is with x. So minor axis is on the x-axis. A is square root of this 11 over 4. B is square root of this 11 over 5. C squared is A squared minus B squared. Simplify, you get all of this quantity. When I take square root, C is 33 over 20. The foci are on the y-axis. The vertices are on the y-axis. And the co-vertices are on the x-axis. So this is your picture. Okay. All of this held true because the larger quantity, larger denominator went with y. So the foci are on the y-axis. Vertices are on the y-axis. Co-vertices are on the x-axis. This is the major axis. This is the minor axis. All right. Next video, we will work on hyperbolas.